This is 2.6.8, and we're given a random variable x. We have the PDF, little f of x is 2x, and that's for x's between 0 and 1. And then it wants us to find the PDF of y and expected value y for these new random variables y. So we're making new random variables. Or we're doing, if you prefer, transformations. Now to find the PDF, it's a very long, seems very, very convoluted process. The logic is there, the logic is down, but I admit it seems very convoluted. One of the first things I'm going to do is let's just find the CDF of x. And we're not worrying about y yet, we're just going to find the CDF of x because I know it's going to come in handy. So the CDF of x, capital F, and I'll put a little x here so I know it's for x. How do you find the CDF? You integrate your PDF. So we'll integrate, and we're supposed to change it and do a new variable, so we'll say a t from 0 to x. And this would give me t squared evaluated from 0 to x, which just gives me x squared minus 0, or x squared. Okay, so there's my CDF of x, and I'm doing this because I know it will come in handy. Okay, now that I've done all that, let's try one of these problems. So let's do B, so you can do A on your own. B says y equals the square root of x. And I want to find the PDF of y. Now it seems, again, kind of a long, convoluted thing. The only way we figure out how to do this is by switching the CDFs, the cumulative distribution functions. So we kind of do a little switcheroo with the CDFs, which is why we found the CDF of above. So you start with saying, okay, I want to find the CDF of y. So let's find CDF of y. Not our end goal, but what we're going to do first. So the CDF of y, by definition, is the probability that y is less than or equal to a little y. But then you say, well, what is y? Y is actually the square root of x. So let's rewrite that with the square root of x. Okay. And now let's solve this little thing for x. So I would have to square both sides of that inequality. So we'll have x less than or equal to y squared. Make sure you don't change the direction of your sign when you're doing these inequalities, or I guess pay attention in case you need to change the direction. So we have the probability that x is less than or equal to y squared. Now, by definition, let me change the colors here. By definition, this is the CDF of x. Okay, so the CDF of x means that this is fx of y squared. Or in other words, let's plug y squared into the CDF of x. So come back up here to our CDF of x, which is x squared. Plug y squared in. So y squared squared gives me y to the 4th. And this is now my CDF of y. So capital F of y is y to the 4th. Now you do need to also check your limits, because your limits might change. So you'll say, if x equals 0, because our limits are x goes from 0 to 1, we set that up above. So if x equals 0, then y equals the square root of 0, which is 0. And if x equals 1, then y equals the square root of 1, which is 1. So the CDF is y to the 4th for y between 0 and 1. Now this still isn't actually what they wanted me to find. The solutions manual makes it seem so short and concise, right? Okay, so what they wanted me to find is the PDF of y. Well, we have the CDF, so we'll take the derivative of the CDF. So the derivative of the CDF, let's see, the CDF is y to the fourth. So we'll take the derivative of y to the fourth, which gives me 4y cubed. So finally, my PDF of y is 4y cubed for y between 0 and 1.